When we look at the two equations, we can write some lines to explain what's going on. I'm going to let distance be represented by y, and I'm going to let time since the start be represented by x. You can work it out using d and t, but I'm changing to x and y just because what we're familiar with, and that's able to graph. So first we need to consider, well, it doesn't matter which one we consider first, but I'm going to choose the car. So for the car, if we're to write an equation for how far the distance is equal to 0.2x. Remember, we're saying that x is the time since the start. To be clear, we'll put that in minutes. If x is in minutes, then that means that the distance that the car has gone is 1/5 of the number of minutes that it's gone. And we also need to be clear that y, the distance, is in kilometres. It doesn't really change how we solve the equations, but it's important to remember that these equations are representing a real thing, in this case the tiger running and the car driving. So by just knowing what units we're talking about, we can think, does my answer make sense? Is this a mathematical representation of what's really going on? For the tiger, we need a little bit more complicated, because the distance that the tiger has gone is 0.5 times the number of minutes. But remember, it took him 6 minutes to break down the fence. So mathematically, we represent that as y equals 0.5 bracket x minus 6 close bracket. So what we have here now is two equations. These two equations are equal at the point at which the tiger reaches the car. The tiger's travelling faster than the car, but has the time that he needs to break down the gate. So he's travelling faster, but the other guys have a head start, so he's going to catch up to them at some point. On the graph, that would be the point at which the lines intersect. What we have here is the two equations, the tiger and the zookeeper, and you'll see that where they cross is the point at which x is equal and y is equal in both equations, and that's what we're going to work out algebraically. We could do a graph, and that's a good way to solve it, but it does have its limitations like any method. Another way to solve this simultaneous equation is to do it algebraically. In order to do that, we're finding out algebraically where do the lines cross on the graph, but we're also saying that for the car and the tiger to meet each other, then the distance and the time must be the same. So that means that y in this equation must equal y in this equation, and x in this equation must equal x in this equation. The whole basis of working out simultaneous equation is based around that. We've got two equations. When y is the same value in both and x is the same value in both, then the lines cross. And we're going to use that to work this out. You can only substitute one equation into the other if you're saying that x and y are equal in the two equations, and that's exactly what we're saying here. In order to solve these equations simultaneously, I'm going to start with one. It doesn't matter which one. In this case, I'm going to choose the car equation, but it doesn't matter which one. I'm choosing the car equation because it's simpler and easier to rearrange, but you're going to have the same amount of working out to do whichever way you approach it. So I need to rearrange this equation so that I get x equals something, which in this case is really easy to do, because if I multiply both sides by 5, I will then get 5y equals x. Because I now know what x equals, I'll rewrite that just to be very clear, I now know that x equals 5y. So I can then come back up to our other equation and substitute that in. I'm going to expand it because expanding is always a good idea. So in order to do that, I just did 0.5 times x gives me 0.5x, and then 0.5 times negative 6 will give me minus 3. I've got this x here, and I said that these equations were true at the same time. So I'm going to use this value up here, which said that x is the same as 5y, and substitute that in here. I know that x equals 5y, so that's what I'm going to put in here. Y equals 0.5 times 5y minus 3. All I need to do then is solve that out. Expand that out. So 0.5 times 5y is 2.5y minus 3. I now have 1y over here and 2.5y over here, so I need to get them on the same side. To avoid any negative numbers, I'm going to subtract y from each side, which will give me 0 equals 1.5y minus 3. Then I'm going to address that constant by adding 3 to each side. So I now have 3 equals 1.5y. I don't want 1.5y, I want 1y, so I'm going to divide both sides by 1.5. So that will give me y equals 2 when I change the sides around as well. So now I have a value for y. What I can then do is go back to the original equations and substitute in y equals 2 to work out what x is. You can go back to either equation, because remember we said that x and y have the same value in each of the equations. So I'm going to come up here, I'm going to pick the easier equation, which is the car equation because it's simpler. Y equals 0.2x. I know that y equals 2 because I just worked that out. So 2 equals 0.2x. I don't want 0.2x. I want 1x. So if I multiply both sides by 5, I now have 10 equals x. So what I now know is that in these equations, the y, which is the distance for them to meet is 2 kilometres, and the time is 10 minutes. So to go back to our original tiger example, that means that the tiger will be chasing the car for 10 minutes over a distance of 2 kilometres. That answer makes sense, which is why it's important to keep track of your units. If we'd ended up with something that was a negative number, for instance, a negative number in this instance wouldn't make sense because we're talking about the time since the beginning and, you know, travelling a distance. So you need to think, do my answers make sense? When we're talking about concrete stuff, a lot of your answers will have both a positive x and a positive y value.